Hello, in this Soma Vision tutorial, I'm just going to go over manual beat detection. Manual meaning like I'm going to hear the song with my ears, and then I'm going to tap on the space bar to say where the beats are. And then the script is going to tell me how many beats per minute the song is. So for example, this is the end result. I press play. And here's a WAV file there that I have some play controls on that I could like move forward and backward. And I could zoom in and out with these keys. Yeah, so let me zoom out a little so we can see more. And then I'm going to press play by hitting the 0 key. So you can hear that. And now if I tap, oh, 115. All right, let me try that again. I know that the song is 120 because I'm playing this one here. So I'm gonna press play. So that's about right. So let me just pause this and take a look at where the beats actually fell. It seems like this is the beat here, but when I tapped, the program recorded it just afterward. And the beats per minute from the tapping detected was 117. So let's take a look at the code. So this code has a lot of things in it, but on this video I just want to concentrate on the tapping. So up here I just have my using statements. I included link so I could query the samples. Did I spell that right? Lambda. And I use system.io so I could output a debugging file. All right, so the script requires the audio source. Here I have some helper things like a class for the point data. A point data is actually each one of these dots, each one of these positions in the line, moving forward one unit at a time, plots a point that represents a group of samples. So the group of samples it represents are the samples per point. Okay, so this point data, I have an index, the time of the point data, the start and end sample that it represents, and the value for the samples that it represents. Then there's a vec3 so I could plot the line. Then there's a vec3 straight so I could plot the position, and a marker in case I do tap that I have that line there, this solid line. And what else do I have? These are my flags there. Is simple, is beat, is tap. So this point data is at a tap. When I press the space bar, if this was the current point data that was playing back that the position was at, then it's a tap. And then I have to calculate the beats per minute. This one is when I'm going to do the automatic beat detection, but this one here, this is the tap beat detection, which is the manual beat detection. Okay, then the song data, just to hold all the points, I have a song data structure, the current playback point, and then what the calculated BPM was, which it's not in this video, I'll do it in the next one, and the manual tap BPM. And then this is the material for the lines. I have material if it's a beat line, a tap line, and a mark line. So the tap line is the scion line right here. So I just have a material because these marker lines, they're not part of my scene objects. I create them in the script. All right, then the BPM data, I need to know the time between 2 points. That's the delta. And then from the delta, I divide 60 by the delta and I get the actual BPM. And then there's the BPM that I round out the actual BPM into a range and I get the BPM. And this child object structure is just so I have a pointer to all those child objects of my song object. There's so many. Okay. All right, so we get down to it. We have the public variables like the samples per point. The meter scale is just something to multiply the sample values for. So the waveform actually goes like bigger than, -1 to 1, which is very small. And the tolerance, I'm not using it in this one yet. The skip forward and skip rewind, that does the like you saw in the beginning when I pressed I was pressing the semicolon and the apostrophe to move the song back and forth, the position of it. Let's see what else we got here. The zoom is for the zooming in and out, which, all right, let me just unpause this. I could zoom in and out. Oops, that's the fast forward and the rewind. And then the zooming my view in and out so I could see more of the wave file. So there's a zoom factor for that. And then the quantize low and high, which is going to be whatever the BPM is that I'm tapping. If it's 240, it's going to like divide it in half so that it's 120. Or if the BPM comes out as really low, like 20 or something like that, then it keeps multiplying it up until it gets into the range. Pause that again. All right, so all these things are just about playing back the song. Here in the start function, I get a pointer to the audio source. I get a pointer to all those child objects, and I have a little helper function I made here called get the child. So it just looks through all the child transforms of the thing I pass in for something named the thing that I give it. Anyway, this gets all the child objects. And then over here, this is where I translate all the samples of the audio source into my point data. So there's more samples than there are point data. All right, so in a song, how many samples are there in an audio source? It's the audio source's clip samples value times the audio source's clip channels value. So channels, if you look over here, these are two channels, a left and a right, and this one here is one channel. So we have to pay attention to the channels, and whatever the samples are, if it's two channels, there'll be one set of samples for the left and the right. So I use audio clip get data to fill in all the samples of the audio source. And if it was a two channel thing, then the way the sample data fills in is basically like the left and the right, left and the right, left and the right, in pairs. If it was a mono, one channel, like this one is a mono over here, then there's no left and right. So it's just value, value, value. So I say like left, left, left all together. Now this is important to remember when we're trying to figure out the position of our playback. So now that I allocated this array samples and filled it in with the data from the waveform, I'm going to allocate my song point array. It's going to be a list. And just because I know I'm going to be putting a lot of points into it, I'm going to set the capacity of the list so that all the allocation is already done in advance. And then as the list keeps adding and adding, it just puts all the values right next to each other in memory. It just helps things go faster, and it helps the memory from being fragmented if I use the capacity and I set it. So now here I go. I'm going to loop through all the samples, but I'm going to loop through them samples per point at a time, which here in our case, the samples per point is 1024 samples at a time. I'm going to keep going every 1024 samples, and I'm going to make a point data object. I'm going to set its index so I know which one it is. So count starts at 0. So this notation here with the plus after means that count will equal 0. So PD IDX will equal 0. And then right after it sets that, plus plus will make count equal count plus 1. Now the start sample and the end sample of where we're going to grab from our sample array. And the time can be figured out for what this point's time will be. I'll use the start sample to set the time for this. And it will be the start sample divided by however many channels there are, because if it's two channels, remember it's left, right, left, right. So I get the sample and then I multiply by the frequency. And what the frequency is, it basically is how many samples were taken per second when this wave file was recorded. So I could use the frequency to go backwards, sample divided by the frequency to get the time, to get the second of this point here. Now for here, since it's a group of samples, since I'm jumping every 1024 samples, I'm gonna group by samples. So if it was one channel, then for every time I add some when I'm going through, I just add samples at I. But if it was 2 channels, then I'll add samples at I, which is the left, and samples at I plus 1, which is the right. Okay, so I add up all the samples in this group of samples, and then I'm going to set the value for this point equal to that sum of samples divided by the samples per point, kind of like getting like an average point sample. And then I multiply it by meter scale, so the value is not so small, and the heights actually go up high enough for me to see. Hi, Grace.
Hi, Daddy.
Then I set a vector 3 for the positioning of the points over here. I have to get a vector 3 for the game object. And then I have a vector 3 straight that I use for positioning this little cursor that's going to move back and forth. So now that sets up the whole point here. The point set up. Now I just add it to the song array. So that's going to loop through all the samples, and now I'm going to have my point array, which will be smaller than the samples were. Okay. The next thing I do is I just set up my material for a beat marker, a tap marker line, and a marker line. And in this tutorial, I'm actually going to use the tap marker line. Now the other thing is this white line over here, just to make sure it matches the size of the wave file, I have to make sure that I set that bottom line scale to how many points I have. So for each point, I'm actually going to take up 1 unit of the scene space for each point. Okay, so that's the width of the bottom line is going to be the point count. And then the position of my start, it was in the middle. This bottom thing, you know, a cube, the Unity puts the position in the center. So right here, the start is an empty game object that I just make sure it's positioned at the beginning of bottom. So to do that, I just say that the position for start is the length and divided by 5, and I say minus because I want the start sample to go to the back.
Bye.
So that should do the that should just set the objects to be big enough to fit the wave on. And now here I draw the waveform. So I use a line renderer object over here. This thing here, it's a line renderer, and it takes positions, and then each position could have it's a vector 3 for each position. So first thing I say for the line renderer object is how many positions are going to be in there. I'm going to have 1 for each point. And then I just use the set positions function, and I feed it the array of my points. But I'm going to feed it using the select statement from my point object. Has a lot of values in it, right? My point object has all these different member variables, but I just want to use this one to set the array. So what this select word here is, this is part of link. This is why I included system.link. Up here I included system.link for lambda expressions, and this is one of the things I could do. So after the dot, if I see things like where, max, select, there's a couple of new functions in here for my collection. If I have the system.link included and I use the select. So now inside of the parentheses here, I write my lambda expression. So what I want to select is x. I want to select from x. That's one of the objects in my point, and this could be anything. This could be like a word like on or y, but I picked the letter x to represent an element from my point array. And what I'm selecting is the vector 3 part of an element from my array. I want the vector 3 part only. And then this part here is an IEnumerable, but the set positions, as you see here, it wants a vector 3 array. So the IEnumerable, I could turn it into an array with the toArray method, and that gives the positions. And then I have a debugging function here that just outputs what all my data looks like to a file. So actually this file exists, and we can see what the data looks like when I click on it here. So I just output information about the audio source, and then here are the actual points. So for this audio source that is playing back right now, it has this many samples and 2 channels. So that's a total of this many samples altogether. So how many points that came out to be was 345 points to represent the, over 350 samples, 350,000 samples. So here's an example, like the first point, the value was 3.5, and the start sample to the end sample was here to here, 1024 for each, right? Then the second point goes from 1024 sample to 247 sample, and its value was that, averaged out. You see the values kind of go up and down, and they're making that waveform picture. And did I tap anything in here? That the tap is not showing. Okay. But my taps they could be in there too. Anyway, that's what the data looks like. And let me continue, because that was, so this start set it up and drew the waveform on the screen. Now in the update function, it checks to see what the current sample of the song is. So when the song is playing, time samples equals the current playing sample. I multiply that by the channels, in case it's a stereo model, and that will equal my actual current time sample. So for my actual current time sample, I'm going to look in my point array again, and I want to get a single element from my array where the time sample is greater than the start sample and the time sample is less than the end sample. Okay, so there should only be one. When we looked at our data, see the start sample and the end sample, they don't overlap. So if the current sample is like 4,000, it's going to fall onto this point number 4, for example. Okay, so that's what this is another link lambda expression, the single statement. And then that element is going to be set to my song CP variable. And now that I have the current point, and each point object has a vector 3 and a vector 3 straight, I'm going to use the vector 3 over here to set the position of the cursor. I'll use the vector 3 straight. And then I'll display the time on the screen with the current point's time value. All right. And then here's the keyboard playback controls, where I have, if you press 0, it plays. If you press P, it pauses and unpauses. And if you press the comma and the period, then you're moving forward or backward in the song. And you could zoom in and out of the WAV file with the semicolon and the period. So these are just some controls to visualize and play back the thing. And now, for the meat and potatoes of this tutorial, it's the keyboard tap function. All right? If the song is playing and I tap the keyboard, okay, the keyboard tap function is going to check to see if I tapped the space bar. If I tap the space bar, I'm going to calculate manually the beats per minute. First thing I'm going to do is whatever that current point data is from the update, see how it figures out the current point data. Whatever that current point data is, I'm going to say that this point data is a tap by setting it to true, the little marker. Then I'm going to make a marker. I'm going to make these a visual blue line at that current point data's space with this create marker function that I made. So basically the create marker function, it's right here. It's just going to take the, to see if the point has a marker or not already. If it doesn't have a marker, then it'll be safe for me to create a quad in my script. Then I'll set the parent of my quad to be the holder, which is this object here. See? Then I'll set the position of this marker using the points vector 3 straight. I use the vector 3 straight to set the cursor too. And then I'll set the size of the marker. So I just made it about 50 high in the Y, because that pretty much shows. All right, so the marker is drawn, and by default, when Unity creates a primitive, the texture I think is usually white. But now I'm going to set my own material on it. So I'm going to I'm going to set the material to whatever was passed in here for material. So I get the markers renderer, and from the renderer I get the material. And I set it to the material that gets passed in. And then I just set the name. All right, so right here, I mark this song point as a tap. I create a little blue line marker for it. And now let's figure out from the taps that are tapped, what is the beats per minute. So I'm going to use lambda expression again. From my point array, I'm just going to select points where is tap equals true. And I'm going to turn it to a list so that my variable here, which is a list, could set the result. If I have more than one tap, then I could actually try to do a calculation, because then I'll have two taps to tell what the time is between them. So I'm going to go through those taps since I have more than one tap, and I'm going to take the first tap, I'm going to skip. Okay, I'm going to start from whatever the second thing I tapped was. So I'm going to do that. So when I say my tap delta could equal my current tap's time minus my last tap's time. That's why I'm going to start at 1 instead of 0. So now that I have a delta, I could divide 60 by that delta to get beats per minute, to get an actual beats per minute. And then sometimes this may come out like really small or really big. It depends on if I tap every note or if I tap every measure. You know, it depends how fast a person's tapping. You know, as long as they're tapping on beat, the actual BPM may be different, but then when I do the quantized BPM, I'll bring it into the same range of beats. Now that I do this for every tap, except the first tap, I get a beats per minute. Now I'll just select all the taps where there was a BPM that was set, and I'll get the average BPM. And that will be my song's manual BPM, and I'll display it here on the screen. And this basically is how I manually detect the beats per minute for a song. So now I could do this with a different song. I did it with this percussive beat, which is 120 beats per minute. And you know, when we did tap it out, it came to be that. Let me try it with this song here, which is untitled. And this one is 140 beats per minute. I made it with Fruity Loops. So now I'll press play and it will load up. And I could zoom out if I want to, or zoom in. I'll zoom out a little bit, or a lot. And then I'll press play. So you see what I did there? I tapped a couple really fast together. But that's okay, it doesn't affect the beats per minute because of the quantization I'm doing. And that came out almost to 140, and that works. And then I could do it with a song actually. So here's a song by Shaggy. I'll press play. And once again, I'll zoom out. And then I'm gonna press play. And you could see that my tap was about 115. So that figured out the beats per minute. And my last thing here, Natasha Bedingfield, I didn't mark what the speed is of this one. Let's find out. Let's press song, stick in Natasha Bedingfield here, and press play, and let's see what the beats per minute is on this Natasha Bedingfield song. I should just make the zoom out be there by default, but here we go. Now I'm going to press play. So that song's about 112 or 111 beats per minute. So let's put that there so we can know. Natasha Bedingfield. Where is the cursor? Let's say that's 112. Okay. Hey, come on. Anyway, well, that's changing the file name. There you go, 112. This tutorial if you need the source code to it, please just go to omarvision.com/tutorials. The website looks like this. Let me bring it up here. This is the omarvision.com website. Just go to tutorials, and it's not there now because I'm making the video right now, but if you type in like beat or audio and then press search, it'll bring up everything that has to do with beat, or let's say audio and search, and it'll bring up everything that has to do with audio. These blue lines are the Unity package, which has everything included that I just did in the demo, or these orange files here. These will be the either images or they will be the actual source files. So you can just see it right here in the browser what the source code looks like. So have fun. You know what? Look at today's date. It's the 25th. Happy holidays to you guys, and I'll see you next time. Bye.